Okay, the last of examples I'm going to work through here involves something. So it's related, but it's not quite the same. And so if you're not careful, you might not see that this falls into the trig substitution. Again, notice we have the difference of squares, but instead of being square root, this is being raised to the second power. Now, this can be done. In fact, this is probably most readily done with trig substitution. But the question is, how do we handle this radical? Well, one thing to do is to notice that, recall from our glory days in basic algebra, that if I have the square root of 4 minus x squared, that's what we'd like to have present, so we could do a trig substitution. If you take this and square it, that is equal to, well, the radical squares off the exponent, or vice versa, and that gives 4 minus x squared. And so here's the thing to notice. The thing to notice is the thing in that red box is right here. It's this. The thing in that red box is this. Those are the same thing, right? And so what we want is this thing. So that thing in that red box is that. Those are the same thing. Since we want this thing in the red box to be squared, that means we want this to be squared, right? And so if this is squared, which is the denominator we have, 4 minus x squared quantity squared is equal to this. It is, look, it's second power squared. So this is square root 4 minus x squared. Let me write that a little bit better. Squared squared is fourth power. So we see that? So if I have a difference of squares squared, I can write that as the radical squared squared, which is fourth power. So this is the same thing as that. This is the denominator with this extra square. Therefore, this is the denominator with this to the fourth power. So we may rewrite this. It's the square root, but it's being raised to the fourth power. Now this goes exactly down the same path we've been working on now for a while. So we label the triangle. This is the difference, so this has to be the first term. The variable vertical if possible. That means the radical has to go here. And we choose. The first choice does not involve the radical, that's sine. So 2 sine theta is equal to x, get the differential. And so that part's exact. Choose the function that does involve the radical. That's going to be cosine, because that's adjacent over hypotenuse. Get rid of the denominator. 2 cosine theta is equal to the radical, and the substitution is exact. All right? So if we substitute x, where's x? X is sitting right here. So the numerator has 2 sine theta. dx, the differential, is also numerator value, so that's times 2 cosine theta d theta. The denominator has the radical to the fourth power. Notice, radical to the fourth power. So it has all of this to the fourth power. All right? So all this to the fourth power. Now we can simplify that. Let's see. We got a bunch of constants here. So 2 times 2 is 4 sine theta cosine theta. And then we have 2 to the fourth is 16, cosine to the fourth, and one of the cosines canceled, and the 4 cancels the 16. So we're left, I'm going to throw the 1/4 out front. I have sine theta over cosine cubed, and we can rewrite that And if the exponent on sine or cosine is odd, you may reserve one of those. It's simplest to reserve the sine. So I'm going to reserve this for the differential and do a u substitution. So this is 1/4 cosine to the -3 theta times sine theta d theta. That's reserved for the differential at u equal cosine. And this is now, you can hand this off to the calculus 1 part of your brain. This now is an ordinary u substitution. Let u equal cosine. Remember, this means, I shouldn't write it this way. I should write this, this is a little bit better way to write this. This is cosine to the -3, right? And so now the du, derivative of cosine is negative sine. Don't want the negative. And the substitution is exact. So what do we inherit out of all that? 1/4 and the negative. And what's cosine to the -3? That's u to the -3. And what is sine theta d theta? That's du with the negative out front. This is now the power rule. This is u to the -2 divided by -2. Let's combine all these constants. 1/4, 1/2, that's positive 1/8, u to the -2. What was u? U is cosine. So that's 1/8. I'm going to write this as cosine theta to the -2. We can write that as 1/8 and move the cosine now to the denominator. And let's leave the 1/8 like it was. 1/8, and then we have 1 over cosine squared. Now, what was cosine? Cosine way back up here. Cosine, well, I'm sorry, we have to go here. We actually could go all the way back up to here. We do actually have cosine, but we don't have cosine squared. We have to square that. And so we can go back to find u, and then, oh, I'm sorry, we've already added these. So we have cosine theta. Cosine theta is this expression squared, or cosine squared. So we have 1/8. I need 1 over that expression squared. It's going to create a complex fraction. That's got to be squared. And if you want, you can just leave it like that. If you want to simplify that, oh my goodness, that's going to be 1/8. This 2 moves to the, you have to multiply by the reciprocal. So that moves to the numerator and gets squared while you're at it. And the square root squared vanishes. And so I suppose the final simplified result, which you don't really need to find, and that's 4 minus x squared, plus the constant, and we're out. As far as I'm concerned, you can stop here. As soon as you find the antiderivative and you're back with the original variable, the problem's finished.